Alright, hey guys, today is April 16th, Thursday. So y'all have a quiz today, so I'm going to briefly go over the quiz just verbally. I'm not going to really spend time doing too many problems, so I've kind of condensed this lesson a little bit. But on the quiz, this is quiz 1 for chapter 13. Numbers 1 and 2 there, you're just setting up the scale factor. So you're telling me basically what the ratio would be and then reduce the ratio. Numbers 3, 4 deal with setting up the proportion. So again, you're telling me what you're solving for x. So you set up the ratio, and then get what the actual ratio is, and then set up the proportion to the other side. So do that. 6 works the same way. You first find what the ratio is, and then set up the proportion. Remember, if you go left to right, you go left to right the second time too. If you go right to left, you go right to left the second time too. Then you do your cross multiplication. And then 5 and 6 deal with the pairs of triangles are congruent. So remember, that's your angle, your side, and your side, angle, side. So you need to remember those similarities and tell me whether or not those are similar. Remember, it has to be proportioned to each other for that to work. So that's your quiz. So take that. Today's actual lesson is going to start on page 548. So I'm going to need you to pay very close attention to this, because this is going to be very definition based, and it's going to be basically figures within figures, and so you have to pay attention to make sure you understand exactly what we're comparing to each other. And so this is similar right triangles, and so your first theorem is on page 548, theorem 13.4. It says an altitude drawn from the right angle to the hypotenuse of a right triangle separates the original triangle into two similar triangles, each of which is similar to the original triangle. And so remember, an altitude goes from a right angle to a side of the triangle, and it forms another right angle. So an altitude goes from an angle to the side at a right angle. And so basically an altitude would just go from this angle B out to AC, and it makes a right angle there. And so that's the definition of altitude. This one's particularly for the right triangle, and so you go from the right angle out to the hypotenuse, the side, and then intersect the hypotenuse at a right angle. And so what that does is, in this case, what it's going to do is it's going to set up a similar triangles. And so notice that it's going to create two triangles within the big one. And so what happens is that I labeled it triangle 2 and triangle 3 just for ease of viewing it. So what's going to happen is this triangle 2 over here is going to be similar to triangle 3. That means they're going to match. They're going to have similarities. They're going to be proportionate. And so triangle 2 is going to be similar to triangle 3. But not only that, triangle 2 is going to be similar to the big triangle that we started with. So 2 is going to be similar to the big triangle we started with. And 3 is also going to be similar to the big triangle we started with. So not only are 2 and 3 similar when we cut it like this, but 2 and 3 are also similar to the big triangle that we started with to begin with. And so that's theorem 13.4. You go from the right angle to the hypotenuse, and it creates the similarities. And so what that means is, if we're actually looking at it, that means the hypotenuse is going to be proportionate to the hypotenuse of these other two. So the hypotenuse for the big triangle is AC. So AC is going to be in proportion to BC, which is the hypotenuse of triangle 2, and the hypotenuse of triangle 3 would be AB, so opposite of the right angle. So those would be in ratio to each other. They'd be the similar ratio. And so the same for the other sides as well. And so you just need to keep that in mind as you're working through the problems, how to actually apply it. Because most of this is going to be understanding the definition and then applying it when we start working the problems. So that's theorem 13.4. Theorem 13.5 is on page 550. And it says, in a right triangle, the altitude to the hypotenuse cuts the hypotenuse into two segments. the length of the altitude is the geometric mean between the lengths of the segments. And so, the geometric mean between the lengths of the two segments of the hypotenuse. And so first you need to know what the geometric mean is. So to do a geometric mean, this is going back a little bit. Basically what a geometric mean does is it sets up a ratio where you then cross multiply. So for example, if you did the geometric mean of 6 and 9, then you're going to put 6 over x equals x over 9. So one of the numbers goes in the numerator over x, and then one of the other denominator, the other number goes in the denominator with x above it. So the 6, you put 6 over x, and then you put the other number 9, you do x over 9. So what happens when you cross multiply, you do 6 times 9 is 54, x times x is x squared. So then we have x squared equals 54. So then solving for x, we square root both sides, and you end up with the square root of 54, which we can rationalize, break down the prime factorization. And so we're going to take the square root of 9 is 3, square root of 6 stays under, and so you end up with x equals 3 square root of 6. And so you only take the positive one, we're only dealing with positive measures here. And so that's how you do the geometric mean. You set it up, the number over x equals x over the other number you're comparing it to, and then cross multiply and solve for x by square rooting both sides. So that is the geometric mean. And so what the theorem is actually saying is that you're going to take, it says in a right triangle, the altitude to the hypotenuse cuts the hypotenuse into two segments. The length of the altitude is the geometric mean between the lengths of the two segments of the hypotenuse. And so the first thing we do is we're going to cut it from the right angle to the hypotenuse at another right angle. And so what it's going to do here is, if we're looking at x to z, the big triangle's hypotenuse, so x to z, the big triangle's hypotenuse, is going to be put over wx, which is the, we'll just name this 1. And so that's the hypotenuse of the hypotenuse of, I'm on the wrong one, sorry. This one's where I'm at. So you're going to cut it down, so d to b. So you're going to set a over x equals x over b. So x over b. So again, all these deal with the altitude dropping down, so they're all going to look similar. And so you drop it down, the geometric mean, you take this number, a to b, over the altitude. So a over x equals x over b. So you just divide that. Once the hypotenuse is broken up, a and b is how you break it up once you cut that. And so you're going to put the a over the altitude equals b over the altitude. I mean x over b. And so it's just the geometric mean at that point. So you would cross multiply, and then take the square root. And so it's important to understand that it's the cut segment a over x and then x over b, and then that's going to be proportionate. The one I skipped to that I was trying to do, got ahead of myself with, is theorem 13.6, which says in a right triangle, the altitude to the hypotenuse divides the hypotenuse into two segments such that the length of the leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg. And so all that is saying is, again, we drop the altitude down, and so if you have the hypotenuse of the big triangle that we started with, which is xz, and then you have the hypotenuse of the smaller triangle here, which is wx. So you put xz, the big one, over wx, and then you put wx over xy, which is the leg. So the leg of the smaller one here. And so xz, the hypotenuse of the big one, over the hypotenuse of the small one, and then you do wx over xy. And so why does that work? Because notice wx is the leg of the big triangle we started with. So you're thinking of this wx represents the leg, and then the other represents the hypotenuse. So they're they're setting up the proportions. So you just have to understand what you're looking at. And once you look at them a while, you'll get better at it. It's kind of hard to explain where you can see it until you actually get working through them. So again, going through that, you have the big hypotenuse, which is xz, over the hypotenuse of this little triangle, which is wx. So the big hypotenuse over this hypotenuse of 1. And then you do the leg of the big one, which is wx, over the leg of the smaller one, which was xy. So big hypotenuse over the small hypotenuse of this first one, then the big leg over the small leg of the first one. And so that is going to be in proportion to each other. So again, you're just going to cross multiply. It's basically doing the geometric mean, and you're solving. All right? It has the second, it works on the other side too. So if this was triangle 2, then you're going to do the hypotenuse of the big one, which is xz. So the hypotenuse of the big one, which is xz, over the hypotenuse of the small one, looking at the smaller triangle 2. So it's xz over wz. So wz is the hypotenuse of triangle 2. So it's xz, the hypotenuse of the big one, over the hypotenuse of triangle 2. And that equals the leg, the other leg of the big triangle, which was wz over the leg of 2, which was yz. And so wz, the leg now of the big triangle, over the leg of the small triangle, yz. And so again, once you see it, you should start to get a little bit more familiar with it. So you're just using the hypotenuse and the leg, depending on where it is. And it works because, of course, these are all going to be similar. So that is theorem 13.6. Now, I'm going to try to leave those up on the board to reference. I'm going to erase this over here. And I'm just going to try to make up a few problems as we go and kind of give y'all some illustrations of applying it. So if we look at, first of all, like number 1, 2, 3, 4, and 5, you're just solving for x, and you're assuming that x is positive. And so like 1, 2, and 3, 1 and 2 is exactly like we did on the last lesson. Number 3 is basically where you're finding the geometric mean. So you're cross multiplying, and you get x squared equals a number, and then square root both sides. Number 4, I'll make one up about like that. We'll do, we'll say x minus 1 over 2 equals 6 over 1. So something similar. So again, you're going to cross multiply on this. So I'm going to do cross multiplication. I'm going to do x minus 1 times 1. So that'll be x minus 1. And I'm going to do 2 times 6 equals 12. So then I'm just solving for x. And so I would add 1, and I would get x equals 13. So again, you're just basically doing cross multiplication and solve for x at that point. Number 5 is going to work the same way, only you're going to end up with an x squared, and then you're going to have to factor that down. And so you're getting, so just do the cross multiplication, and then factor that. So basically you need to remember how to factor. So remember how to factor. If you factored it through, and you wound up with x squared plus 4x equal plus 2. I think that'll work. And so we're going to do the factors of 8. The factors of 8 would be 4 and 2. We'll take that to 4 and 2, and then 8 and 1. So I'll change that to 2x to make it work. So you do the factors of 8, and then and then you're trying to get to an x squared here, and to the 2x. So your factors would be the x, and then the factors here, The minus tells you different signs, and so one's going to have to be a positive, one's going to have to be a negative, and so it would be x plus 4, x minus 2, and then that will check, you would get negative 2x, 4x, 2x. And so all this is saying is you're assuming it's 1, you're assuming it's positive, and so when you solve these, you do x plus 4 equals 0, and so you would end up with x equals negative 4. Over here you do x minus 2 equals 0, and you end up with x equals positive 2. And so you're going to take the positive answer because we're assuming that it's positive here. And so your answer here would be x equals 2. If after you cross multiply and you got this, then you factor it, and you would take x over 2. Remember the factors. Minus sign tells you that these are different signs. Plus sign tells you that it's the same signs and you add them. And you try to get to the middle number. And so that is factoring. And so that on number 5, you're going to have to do something like that. You're going to get an x squared term, and so you're going to have to factor it down. But just remember how to factor it, it should be fine there. So that is through number 5. All right, number 6 through 15 is where the bulk of this lesson comes in. So I'm going to draw a similar figure there. I'll do a B. We'll say that all right, so look at, so for this one, we'll say that AD is, we'll make one else, we'll do AD. Alright, so for this one, you're going to want to fill in, for these problems, you're going to want to fill in the information they give you, that way you can see it and actually see what you're looking at for each problem. And so for number 6, this is going to be similar to it. And so they give us AD here is 20, and then they give us DB is 10, I did on the board, and then I want to know what CD is, I want to know what the altitude of the hypotenuse is. And so what you want to do is using theorem 13.5, so theorem 13.5 over here tells me that A over X is the same as X over B. And so you're going to have to use 13.5 for that one. So 13.5 for this one. So A over X equals X over B. So the segment over the altitude equals the altitude over the other segment. And so I would put 20 over X equals X over 10. And then we're just going to cross multiply to figure that through. So 20 times 10 would be 200. And then X times X equals X squared. So I have the square root of 200 would be what I'm working through here. And then I could try to simplify the square root of 200 down, rationalize it to break it down. But I won't spend time on that. But you would basically do the prime factorization of it, and then pull out pairs at the end. So I'm not going to focus on that in a second time, but pretty much you just cross multiply the square roots, and go from there. So that tells you how to do that one. So that'd be like number 6. I'll do one like number 7. So again, number 7 gives you the same information, except now we're looking for AC. So I'm looking for this. So again, you have to figure out which theorem to use. So what do I have now? Now I have the two sides, and I have the big hypotenuse, and I have the hypotenuse of one of the smaller triangles. And so that's going to tell me to use, I'm going to use theorem 13.6 for this. And so what I'm going to do is, I'm going to set your, where am I at? Hold on. So, The big hypotenuse, you have to know what that is. So if the big hypotenuse is 20 and 10, segmented, that means the big hypotenuse total will be 30. Because remember, for this one, we need to know what the entire hypotenuse is all the way across. That would be our XZ, or in this case, our AD. And so it would be 30. And then what I want to do is I want to find 30 over the hypotenuse for the small one. So the small one, the whole point here is I don't know what that is. And so it's 30 over the X equals, and then remember what we did. It was the big hypotenuse over the over the hypotenuse of the smaller one, and then it was the leg of the big one, which was here, over the leg of the smaller one. And so it would be the X over the 20. So it's the leg, WZ, hold on. Let me make sure I got that right. XZ over, should be 28. So there is where then you're going to cross multiply and work it through. So again, same type problem. You just have to set up the ratio. So it's XZ over WX, big hypotenuse over big hypotenuse, and then it's the leg over the leg. And so it's the big hypotenuse is the 30 over the hypotenuse, which is the 30, and then it's the leg, which is the leg here. So the X, now you're looking at this X here, it's the X of the leg of the big triangle over the leg of the smaller triangle, which was 20. And then you just cross multiply. So you do 30 times 20, which is 60, 600 I mean, and then 600 equals X squared. So then square root both sides, and you get your answer from there. And so that's pretty much the process. Let's look. So that pretty much should get y'all started. So just, I'll give you a little bit of hints on them. So number 6, you're going to use theorem 13.5. Theorem 7, you're going to use 13.6. 8, you're going to use 13.6. 9, you're going to use 13.5. 10, you're going to use 13.6. 11, you're going to use 13.5. 12, you're going to use 13.6. 13, you're going to use 13.6. And then 14, it's really just pretty much straightforward. You're not really even using, they pretty much give you the information, just go straight through and solve. 15, same way, just doing those cross multiplying. And so that'll get you started on those. So again, the big idea here, and if they give you, you may have some where you have to do like I did here, where you have to actually take and find the missing parts. They may give you the 20 and the 10 and not give you the entire hypotenuse. So you have to find what you're looking for. So you may have, they may give it to you 20 and 10, and then you have to add that together to get the entire hypotenuse if that's what you're looking. They also may give it to you where you have, they give you the entire hypotenuse, but we may really only need to use this 20. And so you may have to focus in and say, okay, if they give me this entire thing here is 30, and they give you that this is 10, but what I really need to use is this right here, then you would have to do 30 minus 10 to get this missing part that you're missing. So you may have those parts where they give you something that's not exactly what you're looking for, that you have to either subtract or add something together to get that missing part. But outside of that, it's just using the 3. And so the big thing, one more time to review, just make sure we're clear. So theorem 13.5, you take the segmented leg of the hypotenuse over the altitude, so A over X equals the altitude over the other segmented leg of the hypotenuse, so X over B. For 13.6, you take the big hypotenuse over whatever hypotenuse of the smaller triangles you're looking at. So if we're looking at 1, you take the big hypotenuse over WX, which is the hypotenuse of the other triangle, equals WX, the leg of the big triangle, over XY, the leg of the smaller triangle. And so that's how you set it up. And so just depending on what the numbers are, it changes the problem, but it's pretty much that principle in principle. So that's today's lesson. If you have any questions, the big thing here is if you have questions on this, get with me, because I can maybe help you one-on-one see it a little bit better than trying to explain it out in front without knowing exactly if y'all see it or not. Because that's the whole lesson here, is to be able to see the big triangle and the small triangle in the parts. And so if you don't get that, then you need to contact me so I can help you through that. And so that's today's lesson. Again, your homework then is going to be 1 through 15 on page 3 on 552. So 1 through 15 on page 532. And that will conclude today. So just make sure you're with me, and if you have any questions, contact me.